Hello everyone, welcome to the Tuteetute, and in this video we will see the topic called plane wave in arbitrary direction. So generally the plane wave equation, if you observe, in that phase content will be there, that is e power minus j beta z or e power minus j beta x or e power minus j beta y. What is the meaning of that one? The phase created in the wave because of traveling certain amount of distance, that is given by beta x or beta y or beta z. So regarding that one we are going to see here, but those things are given when the wave is traveling either in the x direction or in the y direction or in the z direction. Instead of traveling the wave in any one of these three directions, if the wave is traveling arbitrarily, that means it may be traveling in between x-axis and y-axis, okay, or in any other direction including the z also. That means when the wave is traveling, okay, the tip of the electromagnetic wave is represented by certain coordinates like x, y, z, and all those three are changing. That means it is traveling obliquely or arbitrarily, like that we can able to tell, okay. So if the wave is traveling arbitrary direction, then what is the electromagnetic wave representation? That is what we are going to see in this particular video, okay. So plane wave in arbitrary direction. So before going to see exactly about this one, just as I said earlier, we will see some representations. So electric field is equal to some initial value, it may be the function of x, y, z. Here mainly I am concentrating on like this, e power minus alpha z and e power minus j beta z and e power j omega t, because electromagnetic wave changes with respect to time and also with respect to space, okay. So z represents spatial coordinate and t represents time, so it is changing with respect to both time and space, okay. So if you are working with phasors, we can suppress the time variation, so you neglect about this one. After doing the analysis, you can able to include e power j omega t, okay. Now you do the concentration on this one, and for simplicity we will take alpha is equal to 0. So simply the representation is given by E naught into e power minus j beta z. That means if you have this phase content, you are conveniently write this particular representation of the electromagnetic wave, either it may be electric field or magnetic field, same thing. So what is the information we can get from this one? Because here z is there, the wave is traveling in z direction. Wave travels in z direction, okay. If the equation is like this, E bar is equal to E naught into e power minus j beta x. What is the meaning of this one? Wave is traveling in the x direction. If I give like this, E naught into e power plus j beta x, wave is traveling in the negative x direction. Here positive x direction. So if the wave is traveling in the positive y direction, how it is represented? E naught into e power minus j beta y. Then, and we will see exactly what is this one, okay. Now for the explanation purpose, we will assume that wave is traveling in the z direction, so that I can work using this one, okay. Positive z direction we have taken. What is beta? Beta is the phase constant, okay. Generally e power j theta will be there. So what is this one? Phase. So this beta z is also phase. Beta z is the phase measured in radians. Measured in radians. Phase is measured in radians. So we don't know the units of beta, for example, but z is the distance only. Distance is measured in meters. So from this one, this product should give radians, means here the beta units must be radians per meter. So using these units we can define the beta. What is that one? Beta is actually phase, okay. Beta is actually phase because here radians are available. So beta is actually phase created by traveling the electromagnetic wave by certain distance. Okay, so phase per distance, that is given by this particular phase constant beta. If the wave is traveling certain amount of distance, then the phase is created. How much amount of phase is because of certain distance traveling? That is given by beta value. So if you know this beta z, that means what? Beta is the phase constant, and beside this one you should know how much distance the wave has been traveled. So if you can able to know that particular distance, here you will put that z value, since that is traveling in the z direction. So conveniently you can able to easily write the electromagnetic wave equation or electric field and magnetic field equation. That is E0 into e power minus j beta z. That's it. So the everything based on this one only. That means representation of the electromagnetic wave can be done conveniently, can be written very easily if you have the information regarding this particular phase concept. So this beta z is the phase, that is the phase you need. Okay, phase is created because of traveling certain amount of distance. So phase constant beta into distance, that is what we need here. If it is traveling in the x direction, e power minus j beta x. If it is traveling in e power y direction, e power minus j beta y. Like that we will give. If it is negative z, negative x, negative y, plus j beta z, plus j beta x, plus j beta y. Like that we will modify that one. Okay. So here mainly the representation of the electromagnetic wave we are going to see. But all these are standard representations, and we are saying that wave is traveling in the positive z direction clearly like that. But the concept is related in this particular video is about the propagation of the plane wave in arbitrary direction. That means when the wave is changing, that is not along just x direction. Okay, so along x direction and along y direction also. That means, for example, if you take like this, the wave is traveling from the origin towards certain amount of point where x coordinate changes. For example, here 0, 0, 0 is there. You assume here antenna is available, it is generating the electromagnetic waves. The generated electromagnetic wave is moving arbitrarily. Okay, not along just x direction, not along just y direction, not along just z direction. It is moving in the space where it can change its values like x1, y1, z1. After certain time, it will be at some other place where the coordinates are x2, y2, z2. That means arbitrarily it is moving. So simply we cannot able to tell beta x, beta y, beta z. That means here all the three coordinates should come. For that particular case, what is the representation? That is what we are going to see here. Okay. So this is the introduction for this particular topic. Now I will take the electromagnetic wave representation when it is in arbitrary direction. So this is x-axis, y-axis, z-axis. X-axis is coming towards you actually, but on the 2D plane we are representing like this. This is the basic already you know. Next, you assume that the electromagnetic wave is moving arbitrarily like this. So this is the wave direction, direction of propagation. Okay, and direction of propagation is actually represented by the k vector. Okay, and the unit vector related to that particular direction is represented by n cap. N cap, and in this direction only we can tell direction of propagation is available, and k bar is also available here only. Okay, so once again I am repeating, if the wave is traveling in the x direction, what is the related unit vector? X cap or I cap. If the wave is traveling along z direction, what is the related unit vector? Y cap or j cap. If the wave is traveling in the z direction, what is the related unit vector? K cap or z cap, or simply we will say AZ cap. Like that people will represent. Okay, now the wave is not traveling like this now. Okay, the wave is traveling arbitrarily. While it is traveling, all the xyz three coordinates are changing. So arbitrarily it is traveling. So the related unit vector we are representing with the n cap. So n cap is unit vector related to direction of propagation of the electromagnetic wave which is traveling in arbitrary direction. Okay. So since it is unit vector, what is the magnitude of this particular unit vector? 1. Okay, that is why that is called unit vector. Okay. Then this unit vector is making some angles. Okay, surely it will make some angles. Okay. With respect to x-axis, y-axis, z-axis. That is what I am going to represent here. So, like this particular n cap vector is available. Okay, that is making the angles phi x with respect to x-axis and phi y with respect to y-axis and phi z with respect to z-axis. Okay, first we are going to write the mathematical vector representation of n cap. For that, what are the angles made by the unit vector n cap with x-axis, y-axis, z-axis we have taken? Those angles are simply phi x, phi y, phi z. What is the necessity of considering these angles means, now our job is to get the mathematical vector representation of the n cap. Generally, how we will represent the vector a bar? For example, if you take vector a bar, that is like 2x cap plus 3y cap plus 4z cap. Like this one vector is there. How we will represent this one? What is the meaning of 2, 3, 4 here? Generally, 2 is the projection of a bar on the x-axis. 3 is the projection of a bar on y-axis. 4 is the projection of a bar on z-axis. That means, if you have the projections of a bar on x-axis, y-axis, z-axis respectively, then you can represent mathematically or vector form you can able to give for one particular vector. Similarly, here my job is to get the n cap representation vectorially. For that purpose, what I need to have? The n cap projections I need. Here a bar projections are 2, 3, 4 on x, y, z. Like that, what are the projections of n cap on x, y, z? That is what I need. Okay, what are the projections of n cap on x, y, z? That is what I need. So for that, what we need to do? For example, this is b bar vector and here I have c bar vector. How to get the projection? What is the meaning of the projection? We have to draw one perpendicular from the c bar on b bar. Then this length is called projection of c bar on b bar. That is the terminology we need to use here. And if you assume here theta is the angle, then according to this right angle triangle, we can take this length is mod c cos theta. Mod c cos theta. So from here to here it is mod c cos theta. If this entire projection is multiplied by this b bar length, then that is called b bar dot c bar. Okay, this length mod c cos theta, if you multiply with mod b, that is bc cos theta, that is equal to b bar dot c bar. Generally, dot product is defined like this. Okay, now how to get this component or projection of c bar on b bar? How did we get here? Just we have taken magnitude of this c bar and multiplied with cos theta. Okay, theta is the angle between these two vectors. So once again I am repeating, I am looking for the projection of c bar on b bar. Okay, this is required to understand the representation of the n cap. That is why I am spending the time here. So listen carefully. Using this particular concept, what we are getting? The projection of c bar on b bar. How to get that one? We need to draw one perpendicular which is making 90 degrees here. So this length we need from here to here. That is obtained by providing this cos function. So magnitude of c is the hypotenuse here. So mod c cos theta. Then this is representing the component of or the projection of c bar on b bar. Now what is this to? Projection of a bar on x-axis. Projection of a bar on y-axis is 3. Projection of a bar on z-axis is 4. Like that, now I need projections of n cap. Okay, projections of n cap on xyz axis I need. Then I can able to provide the representation of the n cap. So n cap is equal to, if you have the projection of n cap on x-axis, that is to be written here, then x cap plus projection of n cap on y-axis if you have, that is to be written here, into y cap plus projection of n cap on z-axis is to be written here, then z cap. Like this we can able to represent the n cap. Okay, this is a unit vector related to direction of propagation of the electromagnetic wave. So here we need the mathematical representation. So how to get that one? Projection of C bar on B bar, how did we get? Magnitude of C cos theta. Okay, cos of the angle between C bar and B bar. Similarly, magnitude of n cap into cos of the angle between n cap and x cap, that is phi x. Already I have taken here phi x, phi y, phi z. Phi x, phi y, phi z are the angles made by n cap with respect to x, y, z axis respectively. So to get the projection, what we need to do? Magnitude of C and cos theta. So using that concept, here also I have done same thing. Here I need the projection of n cap on x axis. For that purpose, magnitude of n cap into cos phi x. Cos angle we need, and angle made by n cap on x axis with respect to x axis is phi x. Similarly, what is the projection of n cap on y axis? Magnitude of n cap, okay, cos of the angle between n cap and y cap, that is phi y. Okay, that means y axis. Next, here also same thing, magnitude of n cap and cos of the angle phi z. Okay, so now anyway n cap is the unit vector, its magnitude is 1. So finally we can write n cap is equal to cos phi x, x cap, cos phi y, y cap plus cos phi z, z cap. So in this way we can represent the unit vector n cap. Okay, so it is related to direction of propagation, and it is given by cos phi x, x cap plus cos phi y, y cap plus cos phi z, z cap. Okay, now so this particular direction, in that particular direction we need unit vector, that is what we got here. Okay, next, now I will take one more thing. So the wave is traveling in arbitrary direction like this. It is x axis, it is y axis, it is z axis. Now what we will do in the sense, we will take constant phase plane here. So what is this one? Constant phase plane. What is the meaning of this one? Constant phase plane. That means on this particular plane all the points are having the same phase. Why do we take this one? We are giving the equation for plane wave, okay, which is traveling in the arbitrary direction. So what is the meaning of the plane wave? And all the plane waves are following this particular constant phase plane. What are the meanings of all these things? Means if you see the electric field and magnetic field, these two are perpendicular to each other. Actually this representation is for coming out. Okay, then its strength is changing now. So this is electric field, this is magnetic field. Now these two have become 0. Next, change the direction. Strength changes. Strength changes. Okay. Next, becoming small. Now if you take the graph like this, you will see exact electromagnetic wave. Okay. So without seeing this envelope, see these arrows only. So this is the electric field. The magnetic field is coming out of whatever I have drawn here, that is coming out. This is there at one plane. Okay. So this thumb is actually representing the H bar, that is represented here like this. Next, electric field is still oriented in the same direction. Magnetic field is oriented in the same direction. Electric field is oriented in the same direction. Magnetic field is oriented in the same direction. So all these things are available in the constant phase plane like this. This is the plane created because of E bar and H bar. Even it is reversed like this. Okay, even this electric field is coming down, this magnetic field immediately will go into the board. Okay, these are the lines representing for into the board. So always this particular electric field and magnetic field are maintaining this constant phase plane. Okay, constant phase is there on this particular plane. It is moving like this. That's why we can able to take this particular thing. Whatever the plane I am showing here, that is what we have taken here. Okay, so this is the origin. We will assume that here one point is there, that is A or OA bar. This is the vector representation we have taken. The point on the plane is, or that particular plane is available at the distance of OA bar. Okay, so this is what we have taken. Now you take one more point on this particular plane, that is P. That is one general point. This P can be any point on the plane, but this OA bar is representing exactly the distance. Okay, the wave has been traveled up to the distance OA bar. That is the main thing here. So wave traveled distance OA bar or magnitude of OA bar. Okay, so why I am telling this one? Initially I have told that to give the mathematical representation for the electric magnetic field, okay, or electric field or magnetic field, what we need to do here? We need phase representation very clearly. So E bar is equal to E naught into e power minus j. This is the phase we have to utilize. How to give phase? With respect to phase constant. Here phase is required. So here beta is actually phase constant. That means radians per meter. So here distance traveled by the wave we have to write. That is OA bar, magnitude of OA bar. That is what we need here. Okay. So that OA bar, if you can able to find, representation is over. Okay. Electric field representation we can able to give like this. So if it is in z direction, simply you will put here z. If it is in x direction, simply here you will put x. If it is in y direction, you will put y. But it is traveling arbitrarily. So in that arbitrary direction, how much distance it has traveled, that is what you need to see. That is given by OA. That OA, if you take here, problem is over. That OA we are going to modify now. Okay. So what is this OA? It is the distance from the origin up to that particular constant phase plane. So the definition of constant phase plane now we have to apply. How to get that one? What is the meaning of constant phase plane? Is nothing but the same plane I am drawing here now. So this is the center point of this one. It is making the distance OA bar, magnitude of OA bar. That is what we have taken. So if you take any other point on this particular plane, that also should satisfy the same condition, that is constant phase. How it is possible? If you take, this is A, if you take any point P here like this, then the projection of this OP on this particular thing should give the same value. Then we can tell that is the constant phase. You take some other point here, then this point is also giving same projection on this particular point, that is OA bar. So all the points available on this particular constant phase, on this particular constant phase plane, are providing the same projection, that is OA bar. So this OA bar now we are going to write in terms of the projection concept again. What is the unit vector related to this one? N cap. And for example, the general point which is for all the points available on this particular plane is given by P. Okay. So using this N cap and OP bar, this is the projection of this particular point. Now this is the position vector of this particular point. So if you take the dot product between these two, what will you get? Using the dot product, what we will get? Projection only. Projection of OP on this particular N bar direction we will get. Okay, see here, N cap dot OP cap, if you take, magnitude of N cap is 1 and magnitude of OP and cos function. So generally what is this one? Cos function and OP means it is a projection only na, and this is must be equal to OA only. Okay, that is what we are telling. So this is the center point and this is the constant distance we can able to tell, and all the points available on this one are making the same projection, because that is there perpendicularly, because we can able to get the same projection values of all the points available on this particular plane with respect to on N cap. On N cap, all are providing the same projections. If you can't able to get here, then you take this particular plane like this. Instead of this one, like this you take. So it is the point and this particular distance is exactly OA. Okay, now P point you take here somewhere, and this is the OP bar. But what is the projection of this one on this n cap? This is n cap na. Over n cap, how much projection is there? Means OA is there for this OP. You take some other point here, Q. This is OQ. That is the position vector of Q with respect to origin. But if you take the projection on n cap, what will you get? OA only you will get. So this OA we can able to define now like n cap dot OP bar. Here already I have shown n cap dot OP bar is nothing but it is giving the projection, that is OA bar. So why we have taken like this? Simply OA bar we can take now, but we have to maintain this constant phase plane concept. So all the points on that particular constant phase plane are having the same projections. What is that projection? OA bar. So we are defining this one, and we have written the equation according to the definition of the constant phase plane. So that we have taken here OA bar is equal to n cap dot OP bar. That P bar can be any one point. Any one point means generally that is represented with XX cap plus YY cap plus ZZ cap. This is actually OP bar. So that is generally we will represent with R bar. OP bar or R bar. That is one general point. Okay, general position vector on that particular constant phase plane. So with this particular analysis, now E bar is equal to E naught into what we have now, e power minus j beta. Here we have to write distance traveled by the wave. So that one already I have taken as OA bar. Okay, and that particular OA bar, just now I have told it is given by n cap dot OP bar, that is equal to n cap dot R bar. So substitute this one here. So OA bar is equal to E naught into e power minus j beta n cap dot R bar. Okay, so in this way we can able to write the electric field equation for arbitrarily traveling wave. Then we are going to modify the form of this one, but main concept is this one. Okay, this is very, very important concept. Okay, when the wave is traveling in the arbitrary direction, how to give the mathematical equation means you need to know how much distance it has traveled. Then the distance has to be multiplied with this beta. Then this will give the phase. If you can able to identify that phase, writing this expression is very convenient. Here we have simplified this one. We have taken attenuation constant is 0. Okay, and we have suppressed the time variation so that we got like this. If you have attenuation constant, you can include that one. Okay, so this is the way of writing the equation here. And that OA bar, according to the constant phase plane concept, we have written n cap dot OP cap. And that is equal to OP cap means generally R bar. So that is what we have written here. Now, this beta into n cap can be taken as the K bar. Okay, this is one new vector. N cap is a unit vector, but in the same direction, beta into n cap is nothing but direction will not be changed. Beta is constant. Okay, phase constant. So beta into n cap means its magnitude is not unity, but direction is n cap direction only. That means direction of propagation. So generally direction of propagation is given by K bar. So now this E bar is equal to, we can write E naught into e power minus j K bar dot R bar. K bar dot R bar. That is what we can able to tell. So generally you will see the equations of the electric field and magnetic field for the electromagnetic wave traveling in the arbitrary direction like this. You will see the equations like this. How this particular K bar has come, how this dot product is represented, all these things clearly here I have given. So from now onwards you will not get any confusion why we are taking here K bar dot R bar, what is K bar, why we have not taken B, like that you will not get the doubts. Okay, so when the wave is traveling arbitrary direction, when the wave is traveling in the arbitrary direction, we can able to take the representation like this, whether it is electric field or magnetic field. But you should remember that what is K bar means beta into n cap. So that is what we have to take. So now the forms of the representation we can able to take by whatever the equations we have. And we know that already n cap is nothing but already we have given the equation, that is cos phi x x cap plus cos phi y y cap plus cos phi z z cap. Okay, now what is r bar? It is general point only na. So xx cap y cap plus z cap. So here we have k bar dot r bar. So k is nothing but beta into n cap. You see this expression. So you can able to find out this one separately. N cap dot r cap. That is why I am writing here. N cap is nothing but this one. It is one vector. R bar is one more vector. So n cap dot r bar is equal to dot product. So x component here it is cos phi x. X component is x. So x cos phi x plus y cos phi y plus z cos phi z. Okay, by performing the dot product between these two, we got this one. So this is n cap dot r cap. This one we can substitute here. So e bar is equal to e naught into e power minus j beta times this entire thing you can able to substitute. What is that one? X cos phi x plus y cos phi y plus z cos phi z. Like this we can write now. Okay, so how did we get this one? Like this. Okay, so here n cap dot r cap means this is what we have substituted, so that we got this one like this. Now multiply this beta inside. So it is equal to e naught into e power minus j. What we can write? Beta cos phi x dot x. That means into x. Okay, plus beta cos phi y into y plus beta cos phi z into z. Like this we can write. Okay, now you see the general representation. If the wave is traveling in z direction, e power minus j z, like this will give. That means e power j. After that here radians are required. Only phase must be there. Okay, so this is the distance. Z is the distance. So remaining part is phase constant having the units of radians per meter. This is radians per meter. This is in meters. Okay, so here also you observe, since the wave is traveling arbitrarily, so x is changing, y is changing, z is changing, so that's why all are involved here. Not just x, not just y, not just z. All are involved because it is traveling arbitrarily. Okay, so what is our condition? After j, here we should have phase, that means radians only. So radians means what is the procedure we have here? Radians per meter into meter. X is the distance measured in meters. Y is the distance measured in meters. Z is the distance measured in meters. So remaining part must be radians per meter. This is radians per meter. This is also radians per meter. That means now along x direction what is the beta? Means beta, that means what is the phase constant is nothing but beta cos of phi x. Along y direction what is the phase constant? Means beta cos phi y. Along z direction what is the phase constant is nothing but beta cos phi z. So these things are represented like this: beta x, beta y and beta z. So this is equal to what we can write? Beta cos phi x, beta cos phi y, beta cos phi z. Like this we can write. Okay, so in this manner we have written. So if you want along x direction, along y direction, along z direction, if you want any changes like this, we have to utilize. Okay, orally the wave is traveling like this. For example, you assume this is x direction, this is y direction, this is z direction. But how the wave is traveling? Like this. Okay, this is x, this is y, this is z. Three are perpendicular to each other. But wave is traveling like this. While it is traveling x in x direction, we are this particular wave components are increasing. In the y direction also increasing. Okay, and z direction also these are changing. That's why the representation is involving all the variables here x, y, z. Okay, and related to x direction, if you want the phase constant, what you need to take? Beta cos phi x you have to take, not simply beta. Beta cos phi x you have to take. Along the y direction, what is the phase constant you have to take? Beta cos phi y. Along z direction, the phase constant is given by beta cos phi z. Those things only I have given. Related to x, related to y, related to z. Okay. So, here you see this is x direction, for example, y direction, z is coming out of the board. Simply we will take like this. And already I have mentioned many times, that is wave is traveling arbitrarily like this. This is the wave direction. After certain distance, if you take the constant phase plane, this is a constant phase plane. After certain distance, the phase plane is moved towards like this. Generally, wave is traveling this direction. This is the wave direction. But already we got here beta x is equal to, what did we get? Beta cos phi x. This is the phase constant along x direction. This direction. But actually wave is traveling in this direction. So along x direction, what is the phase constant? Means this one you have to utilize. And beta y is equal to beta cos phi y. And beta z is equal to beta cos phi z. So related to y direction, related to z direction, phase constants already we got. Why I am writing again in the sense, now we are going to get what is the phase velocity. What is the phase velocity along x direction? So that is represented with Vx. Since it is phase velocity, I am taking Vpx. So it is equal to, velocity is given by omega by phase constant, angular frequency by phase constant. That phase constant we have to take beta x only, since this is the phase velocity along x direction. So that I have taken omega by beta x. So it is equal to omega by, what is beta x? Beta cos phi x. But from the basics we know that omega by beta is the light velocity. Omega by beta is the light velocity. So it is equal to c by cos phi x we got. What is the range of cos? Cos function -1 to +1. Okay. So denominator is less than 1. Okay. Denominator is less than 1 means this entire thing you may get greater than c. Okay. If it is 0.5, 2c you will get. Okay. That means the phase velocity along the z direction is greater than c. Greater than the light velocity we are getting. Is it possible? Any physical quantity cannot able to travel beyond light velocity. That is the principle we have. But here what is happening? The phase velocity along the x direction we got more than light velocity. Is it wrong? No. Mathematically it is correct only. So what is the meaning of this one? Any physical quantity I have told, this phase velocity is not a physical quantity. But electromagnetic wave is physical quantity only. But how it is coming, how this particular phase velocity of the electromagnetic wave along the x direction, how we are getting greater than the light velocity means wave is not traveling in the x direction. That is what we need to remember. Wave is traveling arbitrarily, but you have taken along the x direction, so it may come like this. Okay. Then similarly, if you find phase velocity in the y direction, that is omega by beta y, this is also you will get omega by beta here cos phi y. So it is equal to c by cos phi y. Like this you will get. It is also greater than Vpy is also greater than c we got, and Vpz, it is the phase velocity along z direction, is given by omega by beta z, that is equal to omega by beta cos phi z. So it is also c by cos phi z. So Vpz is also greater than c will get. So greater than c, greater than c, greater than c. Okay. So what we have found in the sense, along x direction, you see why it is coming like this. Okay, just by seeing this particular diagram you can able to understand in an easy way. You see here wave is traveling in this direction. So you see this is point P, this is point Q, and here R, S. PQ is equal to RS. So no problem. Wave is traveling like this. But when the wave is traveling from the point R to S, the phase velocity along x direction is moving. This is PQRS. For example, you take this is T. Okay, the phase along x direction is moving RT distance. You see here, wave is traveling from R to S or P to Q. This distance is same. Okay, but if you take the phase along the x direction is nothing but, along x direction it is lengthier. Compared to RS and PQ, this RT is larger. That's why you are getting more velocity here. Okay. So this is the easy way of understanding this particular thing. So don't think that these expressions are wrong. These expressions are correct only, but what we are talking is not about the electromagnetic wave, because electromagnetic wave is traveling like this, but you are calculating the velocity like this. That is the difference between these two. Okay. But what velocity can be taken in order to account for the electromagnetic wave is nothing but that is the group velocity. So how to define the group velocity now? Again we will get in the group velocity also, we have Vgx, Vgy and Vgz. Group velocity along x, group velocity along y, group velocity along z axis. Now how to take? This group velocity is actually, okay, this group velocity is actually the component. Okay, component value we have to take or the projection value we have to take. For example, this is the RS is actually in this direction only the electromagnetic wave is traveling. So you need to take the projection on the x direction. Now this is the length related to Vgx. If you take the projection like this on the y-axis, this is the length related to Vzy. Same in a similar manner, if you take the projection on the z-axis, that is Vgz. So projection is lesser value only na. So you see this length is smaller. Okay. So that is the projection we have to take. How to get that particular projection? Since this is k bar or n cap, this n cap is making how much angle with the x-axis initially we have taken, that is phi x. Similarly, this n cap is making phi y with respect to y-axis and phi z with respect to z-axis. So how to write this component now? Vgx is equal to V into or Vp, this particular V, sorry, or we can tell, generally V naught we can represent, or with C also we can represent, for example C. Okay, so C into what we can take? Cos phi x. How did we get this one? We are writing velocity component. That's why total velocity, that is light velocity only. Electromagnetic wave is traveling in the free space with light velocity. So that is what I have taken. But this is the group velocity along x-axis. That is a component of this one we have to take. This is C, but component we have to take. So C velocity, that is the complete velocity. We have taken light velocity and component is given by cos phi x. It is like simply here A bar is there. You need to have B bar. So this component you have to take. How will you get here? If it is phi x, A cos phi x. That is what I have taken here. Vgx is equal to C into cos phi x. Okay, in textbooks it may be represented with V naught or something else. So I have represented like this. Since I have given here C, here also I have taken C. So it is equal to, now along y-axis is nothing but the component is C cos phi y. And here C cos phi z. So these are meaningful quantities, okay, because we have taken the projection. Okay, the wave is not traveling in the x direction, so that what we have taken, it is traveling in some other direction, but we have taken the projection of that wave velocity on the x direction, that is Vgx. So it is equal to C into cos phi x. Now you see, cos phi x value is less than 1 only. Okay, since anyway phi x is not 90, not 0, because it is traveling arbitrarily, so it is maybe in between 0 and 90. Okay, like that we can able to take, or whatever it may be, it is not 90, it is not 0, so that its value is less than 1. So it is less than 1 multiplied with C means compulsory we will get Vgx value is less than C only, and Vgy value is less than C only, and Vgz value is less than C only. So we are following the principle, that is the physical quantities are traveling with light velocity or less than the light velocity. So it is true here. So group velocity is meaningful quantity and phase velocity here missing the logic, because here light velocity, more than light velocity we are getting. Okay, now if you see one thing, that is Vpx is multiplied by Vgx. What is happening? You see here C by cos phi x, here C into cos phi x. So what we will get? C square. So like this you can able to make one particular equation. This is a relation among light velocity, phase velocity and group velocity. Similar relations you can able to give with respect to y direction, with respect to z direction also. Okay, so this is the main thing. And here our motto of this particular video lecture is regarding getting the mathematical expression for the plane wave which is traveling in arbitrary direction. That is what already we have seen. So finally I am writing that one. So E is equal to E naught into e power minus j k bar dot r bar. Okay, what is k? K is equal to beta into n cap. Okay, what is n cap? Phi x, x cap plus phi y, y cap plus phi z, z cap. So using these equations we can able to represent the electric field or the magnetic field which are traveling in the arbitrary direction. Okay.